solve the lead code problem, binary tree right side view. So this problem is often asked in Facebook as a phone interview question. It helps to test both the candidate's knowledge of data structures as well as his problem solving skills. So this given a root of a binary tree, you have to imagine yourself standing on the right side of it and return all the values that you can see on the right, ordered from top to bottom. So here they have given an example. By given this binary tree, the return value should be 1, 3, and 4 because they're the rightmost nodes that can be viewed from. Um, and they've also given a few edge cases where if the root is null, we return back an empty list. So some people, I think, rush into this problem and they assume there's a simple traversal where we always return the rightmost node of the tree, and without asking any clarifying questions, they ask, they submit the solution. So this is a case where I think we expect the candidate to ask questions clarifying what do you mean by right side. So here's a case where imagine the 5 had a left or a right child. Since from the right side view, that's the rightmost node at that level. So I've given an example. So for example, here the output should be 1, 3, 4, and 7 because here 7 is the rightmost node at the fourth level. So in this case, so it's not like a simple traversal. This is more like a level order traversal, and we always return the rightmost node in that particular level. So yeah, so this question requires a little bit of clarification and intentionally left this vague by the interviewer, hoping the candidate will discover it. So yeah, let's get started. The way we could do, since it's a level order traversal, we should always use a queue for solving it. So let me first start by creating a list of integers. So this is the one which will be used for storing the result. And let's add a check for the edge case. If root equal to null, we return back an empty list. Now since we are doing a level order traversal, let's create a queue. So I'm going to create two queues. So I think when I solve the problem, you'll understand why I need it. And let's first add the root to the first queue. So then while let's see, missing bracket. So while the first queue is not empty, so this is the first thing we are going to do is that since we are doing a level order traversal and we want to keep track of which is the rightmost node at that particular level, I'm using two queues. So first thing we do is we add all the elements except for the rightmost one into Q2. So now when we finally get Q1.size is equal to 1. So we know that's the rightmost node at that particular level. So let's first retrieve it. So tree node. So for that particular level, since that's the rightmost node, we'll add it to the result. The result.add. So in this case, we'll add 1. For the next time, we'll add a 3 and we'll add 4 and we'll keep adding the rightmost value. Let's also add this to a Q2. So now we have added it. So now Q2 has all the nodes at the particular, at the current level. So in order to get the nodes at the new level, let's now create a for loop. Again, I missed the bracket here. So if temp.left not equal to null, we'll add it. So since it's in Q we have the first in first out principle, we always want to print the rightmost element. We'll add the elements in order from left to right. Sorry about that. Okay, having a bad day. And finally, at the end of this, we'll return the result. So let's do a recap of what we did. We created list integer. So this is the one which we'll be using to keep track of the rightmost element. Then we are using two queues. So this is basically a helpful to us to traverse. The first time we are going to add all the elements except the rightmost one into Q2. Then we are going to add the rightmost element to the result. After that is done, we add back all the elements from the current level. I'm sorry, we should first add back the children of all the nodes at the current level into Q1. And we keep doing it until Q1 is empty. So that way we have reached the end of the binary tree. So let's do a run to see if it works. Oh, I think I missed a few. Oh. So yeah, all the three use cases have passed. Let's try submitting it. So yeah, I think this one was able to beat. I guess we could have done much better, but we are beating 70% of other, submissions. So yeah, this is the solution I have. So leave any comments and let me know if there's an easier way. Some people have solved it through recursion, but I think having a queue makes it easier to understand and makes the code more readable. So yeah, thank you for joining.